Hello and welcome to my video. For a given triangle ABC, we want to decrease the side length AB by X% while B is fixed and increase the side length BC by Y% while B is fixed, so that the resulting triangle, drawn here in dashed line, has the same area as the original one. Express Y in terms of X. Okay, first let's set up some notations. So let BC equals A and length AB equals C, and let's denote the newly formed triangle as A prime BC prime. So here this length is decreased by X% and this length is increased by Y%. Alright, so first we have to calculate the new side length, and the side length BA prime is, since it is decreased by X%, it is C times 1 minus X over 100, and the side length BC prime is, since it is increased by Y%, it is A times 1 plus Y over 100. So therefore, since these two areas are the same, we can set up the equation. Here, the area of the triangle AVC can be calculated as 1 over 2 AC sine B. And the area of the triangle A prime BC prime is 1 over 2 A times 1 plus Y over 100 times C times 1 minus X over 100 times sine B. Okay, so 1 over half cancels out, and A cancels out, C cancels out, and also sine B cancels out. So basically we have 1 at the left-hand side equals 1 plus Y over 100, 1 minus X over 100. Now all we have to do is to simply solve for Y, so let's do that. 1 plus Y over 100 is 1 over 1 minus X over 100, which is again simply 100 over 100 minus X. So therefore, Y over 100 is 100 over 100 minus X minus 1, which is simply X over 100 minus X. So therefore, we have Y equals 100x over 100 minus x. And this is our answer, Y in terms of x. Okay, now let's actually inspect this answer a little bit further. For example, between x and y, which one is actually bigger? Well, if we subtract x from y, then we have 100x, 100 minus x, and if we use the common denominator 100 minus x, this is 100 minus x times 100 minus x. And if we calculate that, we obtain x squared over 100 minus x. And you can see that this is positive. So this means that y is larger than x. So therefore, if we want to decrease the length AB by say 10%, then in order to maintain the same area, the length BC must be increased by not just 10%, but actually more than 10%. But what happens when it is increased only by 10%? Right, so let us take a look at the general case here. Here, the length AB is decreased by X%, and the length BC is increased by same percentage, the x percent instead of y percent, then the area of the new triangle is 1/2 times BC prime equals a times 1 over x over 100, and BA prime equals c times 1 minus x over 100 times sine b. So it is 1 plus x over 100 times 1 minus x over 100 times 1/2 AC sine b, which means that it is 1 minus x squared over 10,000 times the area of the triangle ABC. So clearly, as you can see from this term right here, the area of the triangle actually becomes 0.01 x squared percent smaller. So obviously, decreasing the length by x percent and increase the length by x percent do not have the same effect on their products. And that was all for today's video. Thanks for watching, and I will see you in another video.